This is the brand new SmartRing dashboard. I've open sourced all the documentation and design files on my website, so you can follow along and build your own. Let's dive in.
If you saw my last video, I also built an earlier prototype, but after more in-depth research and testing, I realized it wasn't a good fit for open source learning experience. So, I did some upgrading. Dashboard upgrade. Qualcomm pivot. For this new version, I switched from Geely AC63 series into Renesas Bluetooth MCU. It's much better documented and has a strong community support, which makes it far more beginner-friendly. For the heart rate sensor, I moved away from the GH3018 since it's now end of life. Instead, I'm using the Max A6141, which is actively supported and more reliable for long-term projects. I also upgraded the G sensor to a 6-axis IMU. Now you get both acceleration and gyroscope data, which opens up a lot more possibilities for motion tracking and advanced features.
Before designing the final PCB, I first tested everything using breakout boards and development modules. This really helped me validate the power requirements, SPI communication, and firmware behaviors.
For the PPG sensor, I tested with the sensor evaluation board to verify heart rate signal quality and LED configurations. I also tested the 6-axis IMU separately to make sure the acceleration and gyroscope data worked correctly over SPI.
This step was really important because debugging tiny wearable PCBs is much harder once everything is soldered together. By using breakout boards first, I could quickly prototype the firmware, test different configurations, and reduce the risk of hardware redesigns later. After validating everything individually, I merged all the tested circuits into this final dashboard. For this project, you will need a Renesas DA14531 development kit to act as your debugger. Either the USB or the Pro version will work.
To build this PCB, you can download the GoPro files and bomb on GitHub. I'm using JLC PCB to manufacture the board. Once you upload the GoPro files, you can leave almost everything in default, but there are two settings you need to change. Enable field via and choose the 0.15 via size option. This is required because the PPG sensor uses a WLCSP package, so we need via in pad technology. If you want to reduce cost, you can modify the design slightly, and I will mention how to do that in the PCB overview section. You can also use their SMT services, but I will be assembling them myself this time. Well, just for fun. So for the stand cell, I select 150x150 size to match my stand cell holder, but you can adjust that based on your setup. To save some money, you can apply for some coupons, and I also talked with JLC PCB, and you can use my coupon code to save extra as well.
For those who are more interested in the app side and want an actual ring to wear and program, hang tight. I'll be releasing a finished, fully enclosed version once everything is finalized and well tested. You will receive something like this, and after soldering everything, you will get this complete dashboard.
In the schematic, I added detailed notes next to each component explaining the design decisions. I also take the advice from this comment, so now all the communication interface is in SPI. For the PCB layout, I put all the components in a linear format. If you used smaller components, this design can actually start to resemble a real SmartRing. If you'd like to save some money, you can disconnect these two lines and remove these two vias. These are the interrupt signals for the PPG sensors. They are not strictly required and won't really affect the overall functionality, so it's a safe way for cost optimization.
Also, if you have any suggestions or improvements for designing the SmartRing PCB antenna, feel free to let me or the community know. This is a basic tutorial on how to get started with this project. More details and instructions are available in my website, and I will keep posting and updating as things get changed. Now, all the files are ready and open sourced. I hope you can start taking a look and see how things work. If there's any issue or concern, you can comment below, submit a GitHub issue, or the best, ask the question in the Discord server. It's still a long way to turn this project into an actual product, but in the next video, you should see some huge progress. Please subscribe.